Welcome to this evening's webinar on Eco-Retrofit for Householders, Unit 3, Insulation. I'm really delighted to have Richard Shears of Snug Spaces here to talk to us this evening. So today I'm going to spend a couple of minutes just doing an introduction, then it'll be over to Richard to give his presentation. Towards the end we'll have time for your questions, which I'll put to Richard, and then we'll wrap up at about 7:20 with a poll and a couple of information about the next couple of events. So for those of you who haven't come across Cumbria Action for Sustainability before, please do find out about us. Do look on our website. I'm not going to repeat this information here now because I've said it on other presentations as well, but we do lots of different projects with communities, businesses and individuals. In terms of energy services, I work on the energy services team at CAfS, and we have a range of free services, things like general advice calls, free retrofit phone consultations, and also our paid for services like the home retrofit planner, which is an energy audit and an energy model. And we do some other advice as well. And of course, we run courses and webinars like this one, some of which are free, some of which you'd pay for. This one's free because of the energy redress funding that we've received, but we're also really delighted to those of you who give us a donation when you log on or from the CAfS website. It really helps us go further with what we're doing. Richard has been working in the retrofit sector for nearly 10 years now, and does everything really from the assessment of the buildings through to the installation of the measures himself, and has extensive knowledge of lots of different retrofits now, and is used to helping homeowners through the complex range of things that can be done to their homes. So he's like at the sharp end actually doing it, and he's also got a bunch of qualifications from the AECB Carbon Light Retrofit scheme, the Retrofit Coordinator qualification, and Passive House Tradesperson and other schemes. So we're really lucky to have Richard here and a lot of expertise which he'll be drawing on for this presentation. So over to you, Richard.
Great, thank you. That was quite an introduction. Sorry, that was my screen jumped as I tried to share my screen.
Don't worry, that's fine.
Okay, so yeah, I'll be talking to you about insulation today. It's the third unit in this series. The slides. So I work with People Powered Retrofit as our assessor and as a coordinator for them. So just go through what we're going to talk about today. We could talk about the whole house approach and why to insulate, insulation approaches and materials, insulation performance, so things like thermal conductivity and U values. We'll discuss regulations, standards, and obviously quality of the work as well, and then we'll wrap up, and hopefully I'll get through all that in about 40 or 50 minutes. So yeah, Tina's done a very good job of introducing me, so I'll skip to the People Powered Retrofit. You may well have heard of them already. That they're an organisation in Manchester, which is very similar to CAfS. They're a not-for-profit service for householders. They offer clear, independent advice and support to help householders plan, procure, and deliver retrofit projects to a high standard. And they also offer contractor training services and working with CAfS at the minute to deliver these webinars. So what is the whole house retrofit? I suppose it's looking at it going at the whole house as opposed to going at for single measures. So the idea is that you analyse and plan and have a strategy to improve all of the house. So that's walls, floors, doors and windows. But just because the plan is to do the whole house, you don't have to do the whole house all at once. You can stage it. So don't be put off just because it kind of suggests that you should do the whole thing at once. It's important to recognise that the house is a whole system, and that each of the different elements of the house will interact with each other. So I guess the first thing I'd like to do is, if you could put in the chat box, just tell me what systems might interact with each other in a house, and we'll run through a few of those as a starting point. So if you want to just maybe put some things down, what things do you think interact? Maybe ventilation, or yeah, there we go. Yeah, so yeah, oh, that's great. Okay, so yeah, heating, insulation, breathability. Yeah, these are all great. Cavity wall and loft insulation. Yeah, I mean, just the whole host of different answers that people have put down there show that there are a huge amount of different interactions that we need to be careful of. There's a word or a phrase that you hear a lot through this presentation. It's unintended consequences. And if you don't get things right with retrofit, you can end up with things that you didn't want. So planning it is definitely the first step that you need to do. So I don't know if you've seen this before. This is a tool that the STBA have released, which is an interactive guidance tool. So you can put in the measures that you're interested in doing to your property, and it'll tell you which measures they interact with. So you can see in the center there that ventilation pretty much affects everything, and that if you do any measure within a house, then ventilation may well be affected by it. So it's important to think about the context of the building, to think about the house itself, its age, the type of house, where it's situated, its exposure, and these are all factors that you need to think about when you're trying to manage the risk of what you're doing. We'll go through a lot more of this through the next 40 or 50 minutes. So yeah, design, making sure you get the work done properly, it's well installed, and obviously your understanding and the understanding of the other stakeholders in the project as well. So that could be the contractors or the designers. So the process that the approach that we advocate is a fabric first approach. This doesn't mean choosing your cushions and your curtains before you start the project. It's about the fabric of the building. It's the walls, floors, roof, doors and windows. It's the solid structure of the building. And why do we go for the fabric first? It's got a few benefits doing it that way around. If you wanted, I use an example. If you had we used to use boilers to heat our homes, and with boilers you can kind of put any amount of heat into the house. You don't need to really think about the size of it. As long as you get one that's big enough, it'll pump it out. But if you're going to change it to a heat pump, then that's a bit more sensitive to the amount of heat that it can generate. So by reducing the space heating demand and insulating the property, you'll end up with more comfort, and the heat pump will you won't need to use as large a heat pump. There's we'll talk about one. Sorry. So when we talk about fabric first, it's the fabric of the building, it's insulation, air tightness, triple glazed windows. Once we've got those in place, then we can move on to things like choosing the heating system, designing the heating system, lighting and ventilation. And eventually, once we're down those paths, we can start thinking about the generation or renewable energy, so solar panels, solar thermal, that sort of thing. So the next question for you all, why insulate? For your understanding, why would we insulate a building? What Can anyone give me a reason why we might want to do it? If you want to put that in the chat box. Yep. Heat loss, yeah. Keeping the house warm, yeah. Energy consumption, yeah, and comfort, yeah. It's the 3 C's really. It's comfort, carbon, or cost, and they're the main reasons why people insulate or go for retrofit in the first place. So I'll try and address some of those now. Yeah, there we go. So addressing fabric heat loss, reducing space heating demand, reducing peak heating demand, and improving comfort. Now, if you've not heard of those 2 phrases before, the space heating demand and peak heating demand, there is a slight difference between them, which I'll go through in a few slides' time. So addressing heat loss. This is an image of a thermal image of a pair of houses. You can see the one on the right-hand side is has far more red and yellow on it than the one next to it, and also the 2 walls, the gable end wall and the front wall, have different colours as well, and that suggests that the front of the house is leaking a lot of heat. So when you take a thermal imaging picture, that you can calibrate it to the colours of the camera will show different heat loss. And in this picture, I presume that the high heat loss is the white areas and the red areas, and the lower heat loss is the purples and the dark blues. So you can see from that they've got issues with the front of the house there. Okay. Yeah, it's done it again. So this image is an image from the Home Energy Planner, and it just shows a diagram of where heat is lost from a house. So on the first picture on the left-hand side, you've got heat loss from the roof or from thermal bridging, from walls, floors, ventilation, and then as we go right along the picture, you can see that there's improvements been made to each of the elements, and the overall heat loss has been lowered. So how do we measure it? So this is space heating demand. This is, you can see there at the top, it's kilowatt hours per square meter per annum. So it's a way of working out how much property heat, how much it needs over a year's time per square meter. So it means that you can compare 2 different size houses and work out which one has the higher heat loss or a lower heat loss, and it gives you a metric to kind of a target to aim for when you planning your retrofit work. So you can see on the left-hand side here, the UK average is about 140 kilowatt hours per square meter per annum. So that would mean that if you had a house of 100 square meters, you might use 14,000 kilowatt hours of gas to heat your home in a year. So you can work this out from your gas bills. You can tot up all the energy you use, and it'll give you this metric. So you can see where your house is right now, whether it's an average house or better or worse even. And it also means that when you plan your retrofit, you can work out what target you can get to. So at the very far right-hand side, we've got passive house at 15 kilowatt hours a square meter per annum. Next to that is Enefit, which is the retrofit standard for passive house. It's again quite an onerous standard, but something to aim for. And then working back left, you go back towards building regs and building regs before 2000, and it just goes to show that even modern building regs really aren't good enough, and we should be aiming to get a lower energy loss, space heating demand than building regs suggests right now. And it's not impossible. It's a very attainable goal. So there, yeah, what is possible with retrofit? So these are different annual space heating demands for some of the houses that have been modelled using the home energy planner. So in the blue, you've got the before the retrofit, and then in the red and yellow, that's after the retrofit work's been completed. And it's important to show the distinction between the modelled as well and the actual figures, because it's rare that the models will reflect the actual. You can see house 4 there, that the model is actually really close to the actual data, but then afterwards there's quite a sharp difference, and the model is modelled much lower than the actual that was attained. And again, that's called the performance gap. We'll come onto that in on a few slides time as well. So the other way of the other metric that we use to measure retrofit is peak heating demand, which is, like I said, slightly different from space heating demand. So this is the amount of energy that's required to keep a building comfortable during cold winter days. And quite often we use a design temperature, which would be, I think it's -3, but it kind of depends slightly on where you live in the country, and also on the altitudes that you live at. That if you live obviously in the far north on the top of a mountain, the coldest day of the year is going to be a lot colder than if you live in the southwest in a kind of sheltered valley. So we use different numbers to show that, and it's used to size heating systems, and you can also do it room by room, so you can heat, so you can show how much heat you need for individual rooms and what size the radiators will need to be. And it's a pretty important metric, that one. So part of the equation to find it is that you use the external temperature, but also you use the internal temperature as well, and it's the difference between the two. There's the temperature of it. Hang on, let me go back. So it's measured in watts per degree of Kelvin. So that Kelvin part of it is effectively Celsius, but it's a slightly different metric. So Kelvin starts at -273, whereas obviously we're used to Celsius starting at 0, but they do go up at the same increments. So effectively, when we take the external temperature, when we take the external temperature away from the internal temperature, you end up with a number that's about 18 or 19 degrees, or maybe a bit more, depending on what the internal temperature is you use. So yeah, you see here that a recommended internal temperature is often 18 degrees, and the peak heat demand will change depending on what your internal temperature is. If you like to have your house at, say, 21 degrees, the temperature difference between the internal and external might be as much as 26 degrees, which means that you'll have a higher peak heat demand. Whereas if you like your house to be at, say, 18 degrees, the peak heat demand won't be so much. And it's important because when we model it, you can end up having a much higher figure, and it might not be needed, but that's entirely a personal choice. So another reason why we insulate is obviously to improve comfort, and the obvious one that we all know is that it keeps us warm when it's cold outside. It reduces increases internal surface temperatures, so it's warmer to the touch. It can reduce the conduction, and it can reduce condensation on surfaces as well. But it also has, oh no, sorry, my keys aren't working at the minute. But it also keeps us cool while it's hot. So in summer it has an advantage as well, that a well-insulated home in the summer won't heat up as quickly, and so that's a thing called decrement delay. So if you've got a well-insulated roof space, for instance, that area, sorry, not roof space, an attic room, that room won't get as hot as quickly as a room that's uninsulated. Yeah, I mean, that's only part of the issue when it's hot. The comfort, there's also, once you do insulate a building to a high degree, that you then could have problems with overheating, and that part of planning a retrofit is also to plan the what you do with the windows. If you've got a lot of south-facing glass, then you do run the risk of overheating quite a lot, and you're probably wise to think about shade or shutters, or just making sure that you don't overheat too much. And ventilation becomes a major part of this as well, that once you have insulated a building to a high degree, that ventilation becomes a key aspect of that. If you're also increasing air tightness at the same time, then yeah, the ventilation really is key to make sure that you have a comfortable internal temperature and internal environment. So the building types, it says at the top of here, is it's an important aspect. Sorry, I can hear tears from my little boy in the background. I think he's all right. One of the main reasons to retrofit is because a lot of our homes are pre-1960s. They're maybe even pre-1920s. They're old. They weren't designed to operate with modern heating systems. They were designed to operate with open fires, big open fires that would basically heat the walls, heat the whole rooms, and there'd be a lot of airflow through the houses to get rid of the pollutants and smoke from the fires. But it's just not what you want when you've got central heating. Central heating heats the air. It doesn't heat the building or the fabric. So when you've got lots of drafts and air going through the house, it takes all that heat away with it. So the aim of retrofit is to reduce those drafts, to improve the insulation so that heat is kept in. And the key difference between the older homes, that you've got central heating, double glazing and draft proofing in modern homes, but with older homes, traditionally it's coal fires, breathable materials. And that is a key, another aspect that we'll come on to in a minute, that materials in traditional homes are breathable. It's not a phrase I particularly like, but it's one that a lot of people understand, and it works even if it doesn't describe it perfectly. That older properties have a much better way of managing moisture, that as long as you don't put loads of non-breathable things in them, that the moisture will move in and out of them. But we can cover that in when we come to insulation in a bit. This is two pictures of types of bonding of bricks, and unless you're kind of used to looking at the different types of walls, you may well miss the differences. So on the left-hand side, you have a wall with stretcher courses on each course. So that means all the bricks are end on end. And it basically means that there's no bricks bridging across the two leaves, so you have a cavity behind it. And on the right hand side, the smaller squares are the bricks that go through the wall and marry both leaves up with each other, so you have a solid wall. Yeah, I mean that's the easiest way of checking what wall you've got, but sometimes it's just not that simple. From about 1920 onwards, they started. It was pretty much solid walls before then, and then cavity walls after that. But it wasn't a clear-cut jump from one to the other. That there was a lot of there was a okay. Someone's raised their hand. Can you get that for me, Tina? I'm not sure how to find that. I'll carry on. If you could, where was I? Yeah, so there's no clear-cut distinction between cavity walls and solid walls. It starts with small finger cavities, which you still can't insulate all the way up until the 1930s or 40s, when cavities got wider to about 50 mil, which can be insulated, and then up to modern cavities, which are 100 or even up to 150, 200 mil if it's passive house. So what can you do with cavity walls? So you can put cavity wall insulation into them, which has been a common thing to do over the last 30 or 40 years. That initially they weren't insulated; they were left empty. The original idea behind a cavity wall was to allow the outer layer of brick to get wet whilst giving it an air gap behind it, so that the inner leaf didn't get wet from driving rain on coasts and exposed locations. So so you do need to be careful if you're going to go for cavity wall insulation. I always advise people to have it checked before doing it, and I don't mean being checked by the installer, getting someone independent to have a look at it to make sure that it's suitable. So this slide shows a picture of the UK with levels of exposure, and areas with high exposure, so the areas in blue on the left, you can end up having driving rain or really heavy rain events, and it can be really problematic to insulate the cavity wall if you do it in these areas. Unfortunately, I think that kind of covers most of Cumbria, doesn't it?
Yeah, unfortunately so.
Yeah, it's you need to be really careful with it. It's with more modern materials, it's a little bit better. So they use EPS beads, which are pumped in with a glue, and these are normally hydrophobic, so they do give some element of protection against against moisture ingress. But older materials, things like mineral wool or the older beads that didn't do this, they had problems with moisture tracking across the cavity, or the material itself slumping and leaving gaps. So yeah, definitely get it checked before you do it, and also make sure you find a good installer who's got experience of doing it. Some other issues with cavity wall insulation, maybe in the past, but not so much now, is things like off-gassing of the materials. They used to use formaldehyde and polyurethane foam, which is not used so much these days. And also, yeah, vent sleeve. The amount of times I've been into a cellar where they've not sleeved all the vents and there's piles of insulation at the bottom of the house where it's all fallen out. yeah, choosing your installer is a really important factor here. Make sure you get a good one who knows what they're doing. I should also, so this is external wall insulation. You can combine external wall insulation with cavity walls. Ideally, they should be filled before you do it. You can do it with unfilled cavities, but you need to be really careful because you can end up with thermal bypass going right up the back of the cavity, which would render the external wall insulation pretty much useless. I think you really need to get professional advice if you're going to do this. Make sure you find an architect who is well versed in combining the two before you went ahead with it. It's not something that's done regularly, and yeah, you need to be careful. It normally means trying to seal the cavity at the base and at the top. So if the cavity is less than 50 mil, your normal cavity wall installer won't attempt it because they won't be able to get the beads into it. So yeah, make sure you find a professional who can advise you on doing that before you went down that route. If you've got solid walls, then external wall insulation is ideally suited for this. So it's fixed to the outside. In this picture on the left, you can see it's wood fibre boards that has been screwed onto the walls. But you can use, there's other materials, there's mineral wool, or at a push you could use things like PIR or phenolic. Again, it's not something I normally recommend. You need to be really careful with boards like that, especially on traditional homes. And I presume in Cumbria it's going to be quite a lot of stone-built homes and non-standard homes, I guess. So yeah, you really need to choose your materials properly. Things like wood fibre are breathable, and we'll talk about materials shortly, but yeah, wood fibre is a very good material both internally and externally. It can be rendered or clad, or you can put brick slip finishes on it. So if you're not sure, so on the house on the right there, that's the right hand side of that has been rendered, and a brick slip finish is where instead of rendering it, they put on thin slivers of brick, almost tile it in brick, and then grout the surface of it so it looks like it's been it's just a brick surface. Or yeah, you can tile hang as well, so you can put tiles on it. I guess that's a slate tile wall is fairly common in Cumbria as well, for some locations. Maybe not. So some of the pitfalls of external wall insulation, again, it's really down to choosing your installer and making sure they know what they're doing, they've got experience of it. If you can see the house on the right hand side there is there's a red streak up the left hand side of it. Now that is a lamppost that's too close to the building for them to be able to insulate behind it. So they've just left that portion uninsulated, which is one of the main problems of insulation in general, is not creating thermal bridges. And if you choose the wrong external wall insulation contractor, they will quite often leave plenty of thermal bridges. And yeah, I think standards are changing now, but it's been a problem for a few years in the past that through speed or cost or whatever, that people have taken shortcuts, and that things like lampposts and walls aren't thought about and are left. So there's a cold spot. The problem with this example is that there could be condensation on that wall behind, internally on the house, leading to mold and that sort of thing. So yeah, it needs proper thinking about. So you can also internally insulate solid walls. in traditional houses, we have a lot of very lovely facades on the front of buildings, and it's not often that people want to cover them up with rendered insulation. So I think, in my opinion, that a second best option would be to internally insulate. You have to be more careful with this because you're changing the physics of the wall, and that you can end up with things like interstitial condensation behind the insulation. Again, you need to be really careful about the material you choose and the contractor, and make sure you get professional advice before you do it, to make sure that your home's suitable for it and that you put the right level of insulation on it. There's a couple of rules of thumb that you don't really go below 0.35 or 0.4 U value, or you don't put on more than a third of the wall thickness. So if it's a 260 mil wall, you'd probably put on about 80 mil of insulation. Again, there's various materials you can use for that, and if it's traditional building, then wood fibre or cork or maybe diathanite are all products you could use. So the benefits of that one is that you can do it room by room, whereas with external wall insulation, it's pretty much you kind of want to do it all in one hit. Although doing it room by room, it is a bit more disruptive. Quite often you have to take the plaster off, go back to brick, and that is a pretty messy job. You can do it room by room, but you may well end up with months and months or even years of disruption and mess. And if you can do it all at once, Tina's nodding there. If you can do it all at once, then it's probably the best way to go. As with all wall insulation, having a good survey of the walls done to check for damp and check for the condition, working out what the level of exposure is. And it says here, requires good understanding of moisture movement through the wall. And this is so key to it, that walls that don't appear damp now, before you have insulation on them, may well become damp once you put the insulation on. And if you don't have a good idea of where the moisture is going or have a plan for it, then one of those unintended consequences might occur. And it's not always obvious which houses it's going to happen to. That you could have a seemingly really damp house and it doesn't have any worse problems from it, or you could have a seemingly well ventilated dry house and then problems do occur. It's just it's a really difficult issue to deal with. So planning it before you try it is definitely the most very important thing. Pictures, there's a picture further along of problems with wall insulation and things like being aware of hanging pictures, but maybe even kitchen cupboards or anything that's heavy. You need to take that into account before you plan the insulation. If you've got kind of a 80 mil of wood fibre, you're going to find it really difficult to fix anything to that. And although the boards are pretty rigid, it's not the same as drilling into brick, and working out what you're going to hang before you put the insulation on is a really good plan, especially, like I say, if it's heavy kitchen cupboards. So this shows an example of the two different methods, internal wall insulation and external wall insulation, and where you might use them on the same house or why you might use them. So you can see that there's external wall insulation on the gable end that's been rendered, because maybe the gable ends aren't so interesting, or it's just a standard brick. It's down the side of the house, it won't be seen so much. But to do that to the front of the house would change the character of it quite drastically. It may be that planning refused to allow the EWI to go on the front, or just the homeowner wanted to keep the brick at the front. So they've put internal insulation on the front of the wall, on the inside of the front wall. And then it's shown that there's insulation in the loft and the roof as well. But these different aspects of the insulation create junctions between each one of them. So at the corner between the EWI and the IWI, there's a junction there where the wall goes between them. And without proper thought and planning, that in itself can cause issues as well. And likewise with the IWI going over at the top of the wall, that will need to meet with the loft and the roof. If you don't deal with those junctions, you'll end up with thermal bridging, but also it reduces your air tightness. It can be areas where you end up with condensation or mold. It's just an average building contractor who doesn't know retrofit may not think about these things, but if you find a contractor who understands retrofit, or an architect who can talk you through them, then you'll have a much better chance of working out the best ways of doing it. And there's more and more details available and people who can guide you through that. So it's not something you have to do on your own. You can always, there's normally advice you can get from someone. I'm sure CAfS can point you in the direction of people who can help you with those types of details. So loft insulation, it's a pretty common one. I think we're all pretty much aware of loft roll. We've been slapping it into people's lofts for probably 40 or 50 years. You'd be surprised to think there's still about 20% of houses that don't have any insulation in them at all, despite numerous government schemes to try and get them all done. There's still a fair percentage that don't have it. It's really cost effective. It's still relatively cheap compared with the improvement that you get from it. In most cases, you can do it yourself. If you can get into a few narrow spaces, then and not go through ceilings, then it's entirely possible to do it yourself. There's a variety of materials available. I still think loft roll is one of the best. That I know people do put in things like PIR boards or foam boards, but I'm not sure that they're particularly suited in this instance. But there are a few things you need to be aware of. You need to leave air gaps down the sides where it meets the roof. Where you've got storage in there or cold water tanks sitting on the joists, you need to find a way of getting it underneath there. If you do put storage on top of loft insulation, there needs to be an air gap in between the insulation and the boarding out to allow a little bit of ventilation through. You need to be careful for electrical cables and lighting. It's not so important these days, lighting. Now we've pretty much changed to LEDs. But in the past, when it was halogen lighting that was common in ceilings, there needs to be a gap left around it for fire eggs because it can cause overheating. But yeah, like I say, that's not so important these days with LEDs, but you just need to check your lights before you do it. There are other things that you need to do alongside loft insulation. So things like putting thermal hoods over light fittings to make it more airtight, considering putting a new loft hatch in. Quite often loft hatches are just a piece of wood that are kind of just held over the hole, and they're real areas where you'll end up getting a lot of heat loss via the air going through that. And also the more air that comes from the heated space that goes into the cold loft space, it'll take warm moist air into it, which can then cause problems with condensation. And and it's similar things like extractor fans that come from bathrooms that go into loft spaces. Make sure that they go are vented outside, and don't just empty into the loft space. It's a recipe for disaster. That, and I see it quite often where an installer's just put the tube into the loft space.
Yeah,
It's just
they like to hide it under the insulation. That's the popular trick, which is the worst thing they could possibly do. Yeah, so go look for it. Yeah.
Yeah, you can't actually see the spot where the condensation is coming up. You just know it's kind of everywhere. Yeah, you really notice it as well with the drops of water just dropping off all the cold roof membranes or the slates. Or floor insulation. So there's kind of predominantly two types of floor: the suspended timber floors or solid concrete floors, and they both have their inherent problems. With concrete slabs, it's really difficult to insulate them without taking them out. You can put insulation on top, but that limits the amount you can put on top. Obviously, you need to alter door heights. If you've kitchens, you need to alter kitchens sometimes. The stairs as well, it'll mean the bottom step is a different height from the rest. So often it can be a case for taking the whole floor out and redoing it, insulating it, and then putting screed back on top. With timber floors, you can insulate in between the joists or underneath them. But again, we're back to the unintended consequences again, that quite often suspended timber floors were the point that allowed a lot of air to come into the house. And when we had open fires and chimneys, the air would come in through the floor, get heated up and go up through the house. But these days, they're just a source of drafts. So if you close that up, you're losing a significant portion of air coming in, which is a good thing in one respect, but also a bad thing potentially for the floor because it doesn't get ventilated anymore. So you need to make sure that the floor area gets surveyed properly, that there's air bricks around it, that you know that the joists at the floor aren't damp, aren't going to get worse, that there's no kind of standing water down there. Just you need to be careful with floors. They quite often you can end up with problems if you don't plan it out properly. So yeah, here you can see on the left it's upgrading an existing slab. So you can dig up and replace, or another way of doing it is leaving the floor alone and insulating the perimeter of the building. So by putting insulation on the outside of the wall and digging it down into the floor, you lower the heat loss from the whole of the floor area and improve its U value. And this can be as effective as actually changing the floor. The image on the right is suspended floor. So the ideal way is to take the floorboards up and then insulate, put a breather membrane underneath for wind washing and for vapor control, then insulate in between the joists, and then put an airtight membrane on top, so you make the whole structure, the whole assembly airtight. You can do it from underneath if there's, say, a cellar there, or even a crawl space, but it's not as effective. So the benefits, the main benefit is comfort, that, like I say, that you reduce all those drafts that you get in, that even though you're it's your head that hang on, let me get this right. you'll feel cold even if your feet are cold, even despite if your head is warm. So central heating heats the room from top down, so your head will get warmer before your feet will. So if you've got drafts coming in through the floor, cooling your feet down, even though your head might be at 21 degrees, you'll still feel cold. So the main benefit of floor insulation is that it reduces that discomfort from having cold feet. And then it says on here, take care. So access to subfloor void. It is a real issue, the subfloor void, that not just for ventilation and airflow through it, but actually physically getting into it and getting it done. That if you've got a cellar, then that's possible. But once you can start getting down to, say, 500, 600 mil, it becomes really awkward to get into it and to get the insulation on in any meaningful way or in a good way, that you just end up with a subpar installation. And obviously the other thing to be aware of is most people put their pipes and electrics under the floor as well, so that they can not only cause hazards to the installers going underneath it, but they can reduce the effectiveness because you've got wires going through it. You can't maybe get the insulation in properly. It's not always as straightforward as it may seem. So again, getting a proper survey, getting it checked out properly before you start is a good idea. So, what materials to choose? So I've mentioned a fair few materials coming through the presentation so far, and they all have different considerations, the different performance criteria and different types of material. So you can get natural materials or petrochemical materials. You can get fibrous materials or foam, flexible, rigid. There's vapor permeable or non-permeable. There's diffusion through the material or capillary action. Thermal conductivity or fire is a really important aspect to insulation these days. And obviously price as well, that different materials will cost different amounts, and it can be it can be a huge consideration that if you want to go natural, then that might well be more expensive than putting a foam board on. So this is an example of a few different materials. The one in the center is phenolic, which is a bit like PIR, but it's not. It's slightly different. I'm not entirely sure what the difference is. I think the only company that do phenolic is Kingspan. I think they've got the patent on it. It's slightly better performing than PIR. Sorry, PIR is polyurethane, and that's probably the most problematic material. I suggest staying away from it if you can. It's the kind of the Celotex boards. If you are going to go for a foam board, then phenolic is a better option. They do have the best performance of the materials, except for aerogel. Aerogel on the right hand side there was initially devised for the space shuttle to use as its heat shield, and if I've got my maths right, I think it's about 10 times better than phenolic. So it's you only need about 10 mil of it compared to 100 mil of phenolic in the same assembly. And that aerogel is a silica-based fibrous board, normally plaster backed onto plasterboard. It's ideal. It can be used internally or externally, I think, as well. Then on the left-hand side, you've got wood fibre at the bottom, which again is natural. Its performance isn't as good as the other materials. So if you needed 100 mil of phenolic, you might well need 200 mil of wood fibre to get to the same U value. and it's a similar level with mineral wool that, yeah, you probably need about 200 mil to get the same U value. I realise we're really getting through it, so I'm going to speed up a bit. And then on the right hand side, we have EPS, which is a really standard material for external wall insulation, not necessarily used internally as much. So the last bit of the fabric is doors and windows. If you're really going to try and improve a house, then triple glazing is the way to go. Double glazing is good, but triple will probably lower the heat loss from that element by about half from what it is currently. The most important aspect of glazing is its installation. That it's the area around the windows that can be an area of real leakage, and your average installer might not do it to the standard that you require.
Richard, I can save you some time here because we've actually got 2 webinars coming up on Windows specifically. So if you want to just whisk through all the Windows stuff, that's absolutely fine, and just focus on, you know, the walls and the insulation and so on. So yeah, go for it.
Okay. So I'll ask a question, and while you're adding the answers into the chat, I'll carry on. So what features should you consider when choosing insulating materials, and why? So if you were choosing, say, wall insulation, what would be the considerations that you'd need to think about? Yeah, cost, absolutely. If it was, say, a traditional building, what would be yeah, breathability, definitely. If it's traditional building, then breathability is a really important aspect. Yeah, type of wall, yeah, these are all great examples of it. Breathability is a really important one. Finding the contractor, yeah, you've all got it. Definitely, great, okay. So U values, conductivity and performance. So this is an example of different materials and their different conductivity. So conductivity is the rate at which heat transfer goes through the material. So you can see that with copper, solid copper, that's very conductive. And then when you get down to the bottom, PIR or XPS, they're not conductive at all. And this is the basis that we use to, Tina, I can see you're going to jump in.
Yeah, I was just going to say, because it's a big, huge topic to cover, and we are quite short of time. So I just wondered if we could perhaps leave a little bit of the technical information, and also to say to people that we are going to have some more detailed retrofit sessions for builders as webinars. So if people want the very technical detail, there's a second chance after Easter for that, possibly. But if we could look at the things that are, if you like, you could home in on the things that just to sort of finish off in another 10 minutes or so, that would be brilliant, and that would still leave time for some questions.
Okay,
so Windows altogether, because I know that we've got them covered later this month. Yeah.
Okay, I'll skip past U values then. I mean, these are really key and important, but it's a pretty technical area, and actually it might be better to have a quick chat about regulations and standards before I finish. These part A, B, C, F, G, J, and L are the approved documents that we use to make sure we're adhering to building regs. So there's structure, fire, moisture, ventilation, water use, fuel burning, and energy use. Energy use is obviously the most important for retrofit. There's three main standards for retrofit that are used currently, and these are all over and above building regs. So there's the ACB retrofit standard. There's the LETI retrofit guidance standard as well, which has been recently published. That's been in conjunction with ACB, I think, and a few other stakeholders, to come up with a meaningful target that people should aim for. And then obviously there's the passive house standard as well, which is the most onerous of standards, I think. Not onerous, it's the most exacting, and it's not just a building standard, it's kind of a quality assurance scheme as well. So because it starts from the planning of the project right through to the installation and certification at the end, it ensures that you'll get to the standard that you need, and it's the one with the least performance gap, that the modelled house at the beginning is closest to the actuality at the end. Planning, there's a lot of can be a lot of issues with planning, especially when you think doing things like external wall insulation or doors and windows, that you need to you might need to have long conversations with planners to try and get your ideas through, that they may not be happy with what you want to go for, even though it's kind of the best for the building and the best for the climate, and it can be a bit of a minefield at times. Thermal bridging, I've talked about it all the way through, but maybe not in depth. It's again something you need to consider, and using a service like CAfS will help you navigate the thermal bridge aspect of insulation. This is a couple of slides here. So this is an example of external wall insulation with someone's not thought about how they're going to fix the hanging baskets to the wall. And I guess if someone had thought about it before they'd done it, they wouldn't have had that crack in it. And this is another example of poor thought out external wall insulation. Contractors just cut a hole for the boiler flue instead of doing the proper thing and getting an engineer in to extend it. And then you wouldn't end up with the cold spot behind that. Okay, so can you spot the thermal bridges in these photographs? Now, it might actually be a better question to ask, can you spot the insulation in between the thermal bridges? There we go. So contractors tried to save the details of the house, and they've just left these horrible cold spots in between the party wall between the two houses, and then the lintels across the top. And then this one definitely is a terrible example of EWI, one to be avoided definitely. And I think there's more cold bridge in this photograph than there is EWI. This is an example of how not to do it. So you can see across the top, it's not shown so in yellow, but you can see that they've left the traditional gutter at the top and brought the insulation underneath it, and they've only put a wedge of insulation in between the two windows. So yeah, if you get photographs of a contractor of work they've done and show you something like this, then I'd steer clear. Performance gap that I've talked about, and we're kind of running out of time, aren't we?
Yeah, I think if you could summarise it, really, that would be just great. I mean, there is a performance gap, it's worth mentioning it.
Yeah, so the performance gap is always something to think about, but when you're planning your retrofit and planning what insulation you're going to do and where you're going to put it, then the performance or where you want to get to, what's practical to get to. In some houses, it's not practical to go to passive house. It may be that you have to go accept a lower target. What materials will you use? Obviously, sustainable materials would be best, but again, it's not always practical, especially when cost is a factor. Sometimes it's better to do something rather than do nothing because you can't get the right material. And it's what's important to you, I guess. It's that we'll all have different priorities, and it's finding the priority that suits you.
Okay, brilliant. So if your question hasn't been answered by the time we finish this webinar this evening. There might be some chance to get the questions answered in other webinars, particularly the webinars coming up on Windows. And we've got a repeat of our webinar on an introduction to retrofit on Monday. And we've got a webinar on ventilation specifically on Wednesday. So if your questions relate to those kind of things, then come along to those and hopefully we can answer some questions there. But also at CAfS we can offer an advice call with one of our energy advisors, or potentially if you're interested in retrofit and you're thinking about retrofitting your whole house in stages or a step at, or all together, then you can give us a call for a free retrofit consultation by phone. Or if you know that you're going to need the full energy audit, the full energy model, by all means ring us up and ask for a quote and we can tell you what that might cost for the size of your house. So there is our contact details. The future webinars, I mentioned some of those there, and we'll have more after Easter as well, so it's worth keeping an eye out for them. But particularly the Windows ones will be really useful if you're thinking about replacing or installing new Windows. So the next steps, if you would like to receive notifications from CAfS about our webinars, then do sign up for our newsletter, which comes out once a month by email. Do sign up for another webinar, complete our survey if you haven't already done so. There'll be details of that in the follow-up email that will come out to you either tomorrow or early next week. And do get in touch with CAfS if you've got a question. We do have various a range of expertise on our energy team, so we can do these short free advice calls, or we can give you a quote for our whole house energy plan if you're interested. And again, thank you for the donations that some of you've made to CAfS for attending this webinar. And I'd like to just finish off by saying a very big thank you to Richard for answering a lot of questions, for giving us a very wide-ranging presentation on a really large topic of retrofit, and we'll leave it open for a few more minutes to try and answer a couple more of your questions, as there was so much interest. So thank you very much for your questions. It's brilliant to see that everybody's wanting to know and find out more and really go into this a bit more well-informed yourselves. So thank you for attending. Thank you, Richard, for a really interesting presentation and for answering so many questions. And hopefully we'll see you next time, perhaps next week or later on in the month when we're doing our other webinars. And good evening. See you next time.